Hello, everyone. In this lesson, we'll learn about Project 1 of this course. We'll delve into the first task of the S7-1200 PLC, the structure and working principles of the S7-1200 PLC. The target results to be achieved through the study of this task include: 1. Understand the models and hardware structure of the PLC. 2. Master the meanings of various input-output interfaces of the S7-1200 PLC. 3. Memorize the technical specifications of the CPU module of the S7-1200 PLC. 4. Grasp the working principles of the S7-1200 PLC. The knowledge structure of this task comprises 3 parts. The first part covers the S7 series PLC models, including the old models S7-200, S7-300, and S7-400, and the new models S7-1200 and S7-1500. The second part focuses on the hardware structure of the S7-1200, including power modules, AC 220 volts and DC 24 volts, CPU models, CPU 1211C, CPU 1212C, CPU 1214C, CPU 1215C, and CPU 1217C, memory modules, system memory like ROM and user memory like RAM, and input-output modules, digital modules like DI and DQ, and analog modules like AI and AQ. The third part discusses the working principles of the PLC. The PLC adopts the working method of periodic cycle scanning. Now let's begin to learn the knowledge points. First is the PLC introduction. 1. Siemens S7 Series PLC. Siemens S7 Series PLC is a type of programmable logic controller produced by Siemens AG, which is widely used in various automatic control systems. This series is characterized by small size, fast speed, and standardization, while possessing network communication capability, strong functions, and high reliability. Based on application complexity and input-output capability, program size, instruction speed, and communication capability, the main products include old models Logo 0BA6, S7-200, S7-300, and S7-400, and the corresponding new model products Logo 8, S7-200 Smart, S7-1200, and S7-1500. 2. Programming languages for PLC. S7-1200 PLC supports 3 main programming languages: ladder diagram, function block diagram, and structured control language. Ladder diagram is a graphical programming language, mainly used to realize the digital logic control, and it can realize more complicated computational logic by adding branches. Function block diagram is a graphic logic symbol based on Boolean algebra, applicable to realizing more complicated logic controls. Structured control language is a high-level programming language. Besides containing the functions corresponding to ladder diagram and function block diagram commands, it can also apply flow control statements such as conditional judgment, cycle, diversion, and return. In this course, we mainly study the ladder diagram programming language. Now, let's explain Siemens S7-1200 PLC CPU models and hardware structures. 1. CPU models. S7-1200 has several CPU models as follows: CPU 1211C, CPU 1212C, CPU 1214C, CPU 1215C, and CPU 1217C, where C indicates compact type. Take 1214C for example. It specifically includes 14 input points, 10 output points, 2 analog inputs, a working memory of 100 kilobytes, a load memory of 4 megabytes, a bit memory of 8192 bytes, 8 extensible signal modules, and a size of 100 by 100 by 75 millimeters. Other CPU models have certain differences in user memory, ontology integration, I/O, expansion capability, high-speed tally function, high-speed pulse output capacity, etc., which can meet the application requirements for different scales and performances. 2. CPU version types. S7-1200 series PLC is currently the most popular small-size Siemens PLC. It can be classified as three types: AC, DC/RLY, DC/DC/RLY, and DC/DC/DC, according to different CPU versions. The first two letters indicate CPU's power supply mode. AC is 85 to 264 volt alternating current supply, while DC is 24 volt direct current supply. The two middle letters indicate the digital input method, only DC, indicating 24 volt direct current input. The last two letters indicate the digital output method. RLY represents relay output, which can generally be connected to a DC power supply of 5 to 30 volts with a load current of 2 amperes and a power of 30 watts, and an AC power supply of 5 to 250 volts with a load current of 2 amperes and a power of 200 watts. DC represents transistor output, connected to a DC power supply of 24 volts with a load current of 0.5 amperes. In this version, the CPU model is 1214C. It is powered by direct current, the digital inputs are supplied by DC power, the digital outputs are relay-based. 3. Hardware structure. Now, I'll take CPU 1214C DC/DC/DC for example to explain the hardware structure of PLC host module. As shown in the figure, this is a CPU power terminal block, classified as AC supply and DC supply. L1 and N are for AC power supply, typically connected to 220 volts, L+ and M are for DC power supply of 24 volts. This is the sensor power terminal. When it is connected to the power supply, it can provide an external output of DC 24 volts, which can be used for powering sensors, switches, and other input signals. This is the digital input public terminal M, and this is the digital input terminal, namely PLC's input point. This is analog terminal, often used for connecting analog signals such as temperature and pressure. This is digital output terminal, namely PLC's output point. It is commonly used for connecting relays and can also be used for high-speed pulse output to control stepper motors and servo motors. This is the memory card slot, used to store the memory card to expand the storage space, copy CPU programs, and upgrade firmware. On the right side of the CPU module is the signal extension module interface, used to connect the signal module, which can increase the number of digital and analog input/output points. By moving the latch to the left, the signal module is connected to the CPU module. Moving it the right to disconnect. At the bottom left corner of the host module is the Ethernet communication interface, used to communicate with the computer, HMI, other PLCs or devices. Above it is Ethernet communication indicator light to display the network status. On the left side of the host module is the interface between CPU and the communication module. The figure shows the communication module CM1241, RS485 connected to this communication interface. These are CPU running status indicator lights. Run/stop is an indicator light used to display CPU's current working status. Error is a fault display indicator light, with flashing indicating a matching fault in the PLC, and a constant light indicating a hardware failure. Maint is a maintenance indicator light, which will flash when the memory card is inserted. In the middle of the CPU module is an interface used to install optional parts, such as signal board and communication board. The figure shows the communication board SB1232AQ, used to expand the output points. Now let's explain S7-1200 PLC peripheral extension modules. To realize the control of large equipment or multi-stations on site, it is usually required to expand PLC host module. Up to 3 communication modules can be added to the left side, including point-to-point communication module CM1241, Profibus module CM1243-5 and CM1242-5, and Remote Communication Module CP1242-7 GPRS. When the I/O points of the host module are insufficient, signal modules can be added on the right side, such as Digital Input Module SM1221, Digital Output Module SM1222, Analog Input Module SM1231, and Analog Output Module SM1232. The most expandable CPU can accommodate up to 8 signal modules, increasing the total number of digital and analog input/output points to a maximum of 256. Above it is possible to expand with signal board modules, which come in various types including digital input signal boards, digital output signal boards, analog input signal boards, and analog output signal boards. Summary of this lesson. In today's lesson, we provided a detailed overview of the S7 series PLC models and programming languages. Taking CPU 1214C as an example, we explained the hardware structure of S7-1200 in detail. I hope that these contents can help you better understand PLC and lay a solid foundation for subsequent practical applications. That concludes today's lesson. Thank you for your attention. See you next time.